Today we are going to talk about Oracle RMAN. What is RMAN? RMAN stands for Recovery Manager. RMAN is an Oracle database client that performs backup and recovery tasks on your database, and it automates the work of backup strategies like backup, restore and recovering data files. DBAs can use RMAN to protect data on their database rather than requiring backup administrators to initiate them. Oracle RMAN handles the underlying maintenance tasks that must be performed before or after any database backup or recovery. It can conduct incremental backups, block media recovery, binary compression, encrypted backups, automated database duplication, and cross-platform data conversion. A user can log into Oracle RMAN and command it to back up your database. RMAN will then copy the files to the directory specified by the user. By default, RMAN creates backups on disk and generates backup sets rather than image copies. Backup sets can be written to disk or tape. RMAN backup types. RMAN is very flexible and it offers many different types of backups. We need to start with a list of backup types. Full backup. A backup of a data file that includes every allocated block in the file being backed up. A full backup of a data file can be an image copy, in which case every data block is backed up. It can also be stored in a backup set, in which case data file blocks not in use may be skipped. A full backup cannot be part of an incremental backup strategy, that is, it cannot be the parent for a subsequent incremental backup. A full backup backs up all data files in the database is block-by-block backup with everything you need to recover to the point in time when the full backup was collected. Incremental backup. An incremental backup is either a level 0 backup, which includes every block in the file except blocks compressed out because they have never been used, or a level 1 backup, which includes only those blocks that have been changed since the parent backup was taken. A level 0 incremental backup is physically identical to a full backup. The only difference is that the level 0 backup is recorded as an incremental backup in the RMAN repository, so it can be used as the parent for a level 1 backup. There are two types of incremental backups: differentials incremental backup and cumulative incremental backup. Both differential and cumulative incremental backups are smart backups that save time and disk space by only backing up changed files. But they differ significantly in how they do it, and how useful the result is. Making a full backup every day can consume a lot of time, and get very expensive pretty quickly. In order to minimize potential backup times while also saving money on storage media, backing up incremental changes is the only smart way to protect your data. Incremental backup starts with the assumption that only a small portion of your data will change on any given day. Typically, a company will only modify less than 5% of their business data on any given day. If you can isolate these changes into a backup, you could theoretically cut storage costs and backup time by 95%. One of the longest-standing debates within the backup space has to do with deciding which incremental data capture methodology is best, differential incremental or cumulative incremental. What exactly does this mean? Well, incremental data changes can be captured in one of the following two ways. Differentials incremental backup. The first, and most efficient, technique would be to perform a single full backup, and then only copy the data which has changed on a daily basis. This is often called the differential incremental approach. The main advantage of this approach is that it keeps the amount of backup storage to an absolute minimum. Unfortunately, differential incremental can also be a logistical nightmare. If you do a full backup on day 1, and your server crashes on day 100, you'll need to load the first full backup along with the following 100 incremental backup copies. If any of those 100 incremental backups are corrupted, it could potentially cause major problems with the recovery. Also, this added complexity greatly increases the chance of possible human error during the recovery process. Differential incremental backups also offer very slow recovery since you have to load a lot of redundant data during the recovery process. For example, you might load several hundred gigabytes worth of temporary files, only to delete them immediately after. Or you might need to load dozens of copies of a frequently accessed file when you only need to recover the most recent version. There are two common ways to get around this problem. One way is to perform full backups on a regular basis in order to cut down on the number of incremental backups which must be loaded in the event of a data disaster. Today, it's common for companies to perform a full backup on the first of every month, followed by, at most, 30 daily differential incremental backups. Cumulative incremental backup. Another approach would be to consolidate all of the previous daily incremental backups into a single backup storage unit for easy recovery. This is what the cumulative incremental approach tries to do. Every day, a backup is performed which only copies the data that's changed since the original full backup was performed. If you need to recover your systems, you only need to load 2 sets of backup, the original full backup and the last cumulative incremental backup. By simplifying backups in this manner, you can greatly speed up recovery while also reducing the potential for human error. The downside of the cumulative incremental approach is the fact that the required backup storage can grow exponentially. If your data changes only 10 GB per day, your incremental backups can grow to several terabytes pretty quickly. Because of this, a cumulative incremental backup cycle requires short cycles with frequent full backups in order to keep storage costs low. Backup administrators have to fight a constant battle in order to minimize storage costs, backup windows, recovery speeds, and handling complexity. As data growth continues to accelerate, it quickly becomes apparent that a new approach is needed. This new approach must have the efficiency and speed of a differential incremental backup, the simplicity of a cumulative differential backup, and it should completely do away with the need for periodic full backups. Other RMAN backup types. Open. A backup of online, read-write data files when the database is open. Closed. A backup of any part of the target database when it is mounted but not open. Closed backups can be consistent or inconsistent. Consistent. A backup taken when the database is mounted, but not open, after a normal shutdown. The checkpoint SCNs in the data file headers match the header information in the control file. None of the data files has changes beyond its checkpoint. Consistent backups can be restored without recovery. Note, if you restore a consistent backup and open the database in read-write mode without recovery, transactions after the backup are lost. You still need to perform an open reset logs. Inconsistent. A backup of any part of the target database when it is open or when a crash occurred or shutdown abort was run prior to mounting. An inconsistent backup requires recovery to become consistent. Thank you for watching. Please subscribe this channel for more videos, and don't forget to press the bell icon so that you will be notified whenever we upload a new videos.